Um, let's start with Paul. Any updates this week?
Nothing much to report this week. Last week, or for the past week, I've been pretty much unable to work on Lumen. I had a bunch of extra shit land on my plate, so unfortunately did not make any progress.
And just because I was late last week, I think I missed your update. You're focused on or at least you're making efforts on the WASM compiler right now?
Yeah, in a couple different directions. The thing that I had finished up last week, more or less, I still need to integrate with Luke's work, is adding support for the new M1, like Apple Silicon hardware, so that we can compile Lumen and run it on those. And basically, once Luke's update of the Rust compiler is ready, I can integrate those changes. But the larger work that has been going on in the background is the retooling of CodeGen so that it can support lowering for WebAssembly, as well as the approach we've been using for native compilation on non-WASM targets.
Okay. Let's go over to Hans.
I finished up. Let's see, what was I finishing up at the end of the last week? The interpreter changes to the new term representation. So all the tests run on that and null successfully now. Got to remove quite a bit of code, and now I've been working on. One of the things I really wanted to have validated in the tests was that there was there's no violations in how pre-ops could be scheduled, that there's no violations there. So I'm doing like a simple naive pre-op scheduler, so I can validate that everything works correctly in that sense, which is pretty much done as well.
And Luke?
I got the runtime part of the Rust thing working. So that workflow works right now. With the parts that actually use the switcher, I switched over to using the separate global ASM, but the one problem with it is I wasn't sure how to implement the call site table for swap stack. I copied the parts that seemed like they should be the same from dynamic apply, but I wasn't sure if there should be a call stack table. The only reason I copied over was because without adding the CFI start proc and end proc, it said I couldn't use CFI directives. So I knew I had to add like the prologue and epilogue using those directives, but I wasn't sure if we need a call site table in swap stack or not. So right now that I'm stuck with that. I mean, if there's just docs I can read, Paul, that's fine too. But if you can look at it,
I'm not 100% sure I follow. You mean like, are you asking whether or not we need the CFI directives?
Well, right, and I wasn't. So we need the CFI start proc and end proc, but I wasn't sure if we need the LSDA and call site table thing. Like yes. I wasn't. Okay, and so then if that's the case, I wasn't sure what the equivalent. So in din call you have two call sites because you have an exec and a ret, and so there's two entries in the table, and I wasn't sure what the equivalent label should be for the swap stack one.
I mean, you shouldn't have to make any changes to the assembly that was being written or that was originally there.
Right, but the original one didn't have a call site table, and it didn't have like the CFI start proc and end proc. I'm assuming because Rust auto-generated it for you for some reason?
Rust generates the start proc and end proc, but that's easy. You just put those at the beginning and end of the function.
So do I not need the LSDA directive and the call site table at all in swap stack?
I guess I'll have to double check and look real quick.
Yeah, I wasn't sure if for CFI the swap stack counted as call sites or not, since like I know, but I also knew it had to be unwind safe, so I wasn't sure.
The key is that it knows how to unwind back up to the correct location in the stack. And so it's important that the CFI directives point to the correct location. So it needs to know where to find the previous frames.
Right. So those
stack
CFI
and return
restore
address.
stuff still works, and there's still. So like I did start proc, and I did the personality one, and then the CFI LSDA was where it jumps to the table at the end, and then I wasn't sure about the table layout, or whether we even need the LSDA directive.
Oh, you're talking about actually generating the call site table? We don't have to do that. The compiler does that.
Well, it's in your dynamic apply code, so I'm not sure what to put in the swap stack function. Because like if I do do I need to do the CFI LSDA call at all? And if I don't, then like the table kind of disappears because no one's going to jump down there or to like look at the data down there.
Oh my god, my browser could not be going any slower. Jesus. Video calls just destroy performance. Any day. Any day. I mean, I'm struggling to remember without looking at the code right now where I would have ever defined the LSDA in line. Like I set the LSDA because it's important for the apply to know what kind of exceptions flow through that frame.
Right. And that was the thing, was like I thought maybe it was special to apply. So I'm like, do we need the LSDA and the table at the end at all in swap stack? Or do we just need personality function?
I mean, we're trying to make that function behave like a Rust function. So if you're going to set the LSDA, it should match Rust. Since it would now be entirely in assembly, you know, it might not be necessary. But we want Rust to be able to unwind through that function correctly. So yeah, I mean, it does need to be set, and it needs to be set to match Rust's LSDA value. I can't remember off the top of my head what it is. You might have to dump the assembly from Rust or look at like Godbolt or something to see
so
what
that's
it
how you
dumps
figured
for
it out
that.
the first time?
No, I looked it up in the source code, but I couldn't tell you off the top of my head where you could find that now. And it's probably faster to just dump the assembly and look at the first function you find to see what its LSDA value is. You don't need to do any of the fancier exception handling stuff for swap stack. It's sufficient for the encoding to match the Rust encoding, so that when the Rust unwinder is searching up the stack for frames, it finds that one, but it just passes through it. That's
So would it potentially be the case then that, like in apply we have two entries for call exec and call return, but then we have a 0 byte to say no landing pad unwinder will skip over us. Do we just need like those 2 0 bytes to be like we do nothing, just skip over us? Is that potentially the table we need then?
No, what I'm saying is you don't need to construct that table at all.
Okay, so if I don't, because like LSDA says we are a landing pad. You don't think we need a landing pad either? Because like then I'm not sure what address I give LSDA. Because like the LSDA label that we passed to the CFI LSDA directive, we give byte 255 to say we omit the encoding. Then we say 255 to say we have no type entries. Then we start the header where we say the call sign encoding is going to be ULEB 128. Then we calculate the size of the table. We have an entry for exec, an entry for return.
I mean, we definitely don't need the call site table at all for swap stack because we're not intending to handle any exceptions there. We want to just pass through, but it's critical that the CFI directives correctly point to the previous frame so that the unwinder knows how to traverse to the next frame up the stack. The LSDA value might be able to be omitted for that function. I think the unwinder will deal with that properly. I mean, you could try it and see.
Is the CF?
It's tricky anyways with SwapStack because the exception handling, it gets complicated because of course you're switching back and forth between different processes. So yeah, I guess you could try omitting it and see if the exceptions unwind correctly. Which should, result in the process, the top level exception handler being catching that exception. If that doesn't happen, then something is wrong.
Okay.
You definitely don't need a call site table for that function, though. We're not trying to do anything with exceptions there, other than make sure that they pass through correctly. Essentially, we're trying to match Rust's ABI so that panics do the correct thing.
Okay.
Yeah, because since we want that to be treated like a Rust frame, and not a Erlang frame, we want to do whatever Rust is expecting there. And if it can just skip over that frame because it doesn't have any entries, that's fine. I think the problem though is what fuck. I couldn't tell you off the top of my head without double checking. It's possible that the call site table is needed so that debug information gets generated correctly. I guess my recommendation is to see what happens, without it. And if things aren't correct, either debug, the stack trace is wrong, missing frames, or it does not unwind all the way to the top level exception handler, then something's wrong. But that would be the first thing I would attempt. Because that should match, I let Russ set up the function prologue because it insisted on it. So I originally had some of the other CFI directives like start proc, assuming that it didn't generate them, but it does. And that would have included anything that deals with exception handling as well, because that's part of the prologue. It's the second thing it sets up.
Well, I know I need to explicitly have the start proc now because cargo make.
Right. Well, you're defining the function in assembly now, so it's a little bit different. But
yeah, I guess the two entries for the table, like they are literally the one line around the call queue, and if we don't have a call queue, we probably don't need a table at entry at all. I'm not sure if we need the zeros at the end though. I guess I can look up the syntax and see if it's necessary or not, but
I think I documented the structure of the table there, but yeah, you can look it up. The zeros are intentional because they either are data that we're not providing, for example, like cleanup. In the exception handling ABI, there's multiple phases. Cleanup is one of those. We're not ever doing any of that. So those entries.
Oh yeah,
in the tables,
I guess yeah. The first it's not recording the two addresses of the start and end. What's actually recording is right. I see offset size pad, and since we have no call, we have no offset, which means the rest of the stuff doesn't make sense. Which means our table is completely empty. So it really just matter of like, do we have to say we have a zero size call site, or can we completely get rid of it? But if we get rid of it, it almost seems like, are we allowed to use the LSDA directive? Or does that confuse it that we have an entry with we have a table? Because we would have to record that the table's empty for it to know to not keep running down through memory.
It probably has to be set to 0 or omitted entirely without the call site table. The more I think about it.
Okay, I'll see if I can find the docs for LSD and see if it's supposed to be don't call it at all or make an empty table to make it happy.
I'm pretty sure if you set a value, it's going to expect there to be a call site table for it to look at. If it's 0 or not provided, then it doesn't look. But the caveat here is whether or not we need that call site table in order for the debug information to be generated properly.
We don't have a call queue in SwapStack, so what would be our instruction that would be the equivalent?
Well, it's not a call, but it behaves like one.
I guess the resume would that be the resume label would be the equivalent of our call after we've swapped to the other stack and we resume that stack. That's kind of the call point.
Well, what we do for the call site instruction range is just like basically the whole function.
Oh, okay.
Excluding like the prologue and stuff.
Because then we say if an error happens anywhere within these assembly lines, blame it on the call, is what we're saying, right?
Right. We're essentially saying this is the location where like the call effectively happened.
Okay.
But since the way SwapStack works really is effectively returning to do a jump, then the call site is really the return.
Yeah, I guess. And we don't have an explicit return. I guess it's the jump queue at the end of the resume label. That would be our return.
Yeah.
Okay.
Assuming that. I mean.
Oh yeah, because the comment says at this point we return. So yeah, the pop and then the jump of racks is us going to the real code outside of SwapStack. So yeah. Okay, I will try making the size of the table 0 first, see what happens, and then after that I'll also try to look at the CFI LSDA directive to see if we can get rid of it completely.
You can't make the table 0 sized. It has to match it has to have the bare minimum of the struct. Okay. So you either have to omit the LSDA or set it to 0 to say that there is no call site table, or you have to create the table with, the bare minimum entries. And the way I'd set up the call site table in dynamic apply is basically almost the minimum. It actually records the call site there, but it is legal for there to be no call site records. And so in that case, the count of records would be 0, and you'd have to make sure that, the offsets are correct to account for the fact that that's a 0 length array. But
okay.
The structure is documented pretty clearly, I believe, in the LVM documentation. You probably have to hunt for it. I tried to document the layout somewhere. If it's not in that dynamic apply assembly file, it might be somewhere in like the unwind crate. But the authoritative source of that is really LVM, because that's what cares about it anyways.
Okay.
Or at least where it's documented the best. I'll warn you that the documentation is confusing.
Do you know what the first number to CFI LSTA is? Like, why is it 16? Is that because we're going 2 bytes in a certain direction or something?
Why the first value is 16 to which instruction?
The CFI LSTA directive, the first value is 16, and then we give it a label. Do you know why it's 16?
I'm pretty sure that is the encoding value. It tells you what kind of encoding it's using.
Okay, I'll look it up then in the docs to try to figure out what the encodings mean then.
I can tell you which website I was using to like have just documentation of
that'd be
the
great.
CFI directives. It's on the sourceware.org domain. I'll paste it in the channel. But the LSA encoding, the first value is the encoding. And if it's 255, then it means omit. So we probably should set
okay, so we could
255 if we want to omit it. And then if the second argument is not present, or if you set it to 255, there shouldn't be a second argument.
But that makes sense.
If there is a second argument, it's just the symbol name to use.
Even if we omit the LSDA, do we still need the personality function directive?
Yes. If shit.
Because if we don't have LSDA, the LSDA label is immediately inside the GCC accept section. So isn't the personality function using that accept section, and the accept section will be empty, or is that not how that works?
So if we set the personality, the first thing the personality is going to do is try and get its data about the call to be able to unwind further. And so that's where the call site records are necessary.
I guess it would really be, does 255 omit the LSDA work with the Rust personality? And I guess I could just try it and see if it works, right?
Yes, it will work. I think in that case, what happens is Rust sees that the encoding is not its encoding, and so it just continues unwinding. You might have to confirm that. I can't remember for sure.
Okay.
We definitely want to set the personality function, because I think without a personality, it will be unable to unwind.
You won't think it's unwind safe, or the equivalent of it. Okay.
It basically just stops being able to walk up the call tree, because a personality function is what does the unwinding. So if it doesn't have one set, it will hit that frame and just be like, well, this is as far as we can go. So if we don't set the Rust one, which we should, because there's no reason why we can't maintain, compatibility with the Rust personality, the alternative would be to either use ours, which is similar to Rust, or use the default GCC personality. But since we're not explicitly linking that code, it's always present in the core runtime library, so there's no reason why we should not be able to assume that that's there. I would just use the Rust personality, because we know how it behaves, and it's better for us to keep in sync with that, since it matches kind of how the Lumen personality works, and anytime we're making changes there or Rust makes changes upstream, we want to stay in sync with those one way or the other. So it's safer to just stick with that. Definitely the hairiest part of making the tooling here work right is dealing with the CFI directives and the exception handling ABI for like swap stack and the dynamic apply, because without setting that stuff up properly, you either don't get good stack traces like at all, or you're unable to step through code in the debugger. So both of these things are necessary, but they're also super, super tricky. Partially because the documentation is pretty fucking garbage. But it's not like all bad, but man, I can't even tell you how many times I had to reread things to try and make sense of, okay, how do these things fit together? Like nobody's really documented like end to end for like a custom language how you would implement this stuff, and I mostly had to try and figure out why Rust was doing the things it was doing, and compare that to like how GCC was setting that stuff up in its default personality for C++. I think I have it, figured out more or less, but even being away from it for a couple of months without having worked actively on that part, it gets fuzzy. I have to go back and re-look at all the things I wrote about it, my notes and stuff. So, anyways,
LSD with 255 then says that like the load effective address queue is an unsupported reallocation of undefined symbol LTemp 0. So I'm not sure if it likes the directive with 255.
Wait, what was the error?
Unsupported reallocation of undefined symbol LTemp 0. Like it somehow thinks
that's something else.
It somehow thinks the load effective address queue is somehow as a symbol that I didn't name. I'm not sure why. It's a bad error.
You probably need to make sure that the symbol names are.
That line has no symbols. That's the OF offset from RIP going to racks. Like that line.
Is the error coming from the assembler?
I mean, it looks like a Rust error, but I think it's the assembler doing it, but I'm not sure because it's formatted like a Rust error, so it's confusing.
Yeah.
Yeah.
I mean, it should be. I mean, it's definitely not the directive value that's causing that. That sounds to me like what happens when you're relying on a label name being unique and it's not. What I found is that, when Rust is generating labels, it's able to make sure that it's unique for the most part. But when you're writing the assembly by hand, requires a little bit more care. And then also the syntax for labels differs between Mac OS and Linux, so you have to make sure you're using the right label syntax for.
Yeah, I got that from the ones you wrote, where I have to do capital underscore on Mac, and I have to do triple underscore for global labels. And then it's different on Linux. I haven't done the Linux one yet.
Yeah, everything is double underscore prefixed, I think. Global symbols.
Oh, is the double $ before constants different in an actual file as opposed to in the LVM ASM macro? Because it's complaining about that now.
Yeah, the double $ there is, the syntax for a constant value, and then the syntax for injecting a parameter reference or register reference.
So it should just be a single dollar now instead of a double dollar.
Right. So like the reference there was $ number is the number of the like virtual register or whatever. That just gives you, that's like, use template that in here, and then the $ before that is actually what goes before a constant in the raw assembly. At least in the AT&T syntax, I guess.
I was shocked that no one has an online AT&T to Intel thing when I did the LVM to normal ASM thing the first time, and it's just people complaining about it and being like, use a Quake tool.
Wait, say that again?
There's no like online site to just do a conversion between the two syndexes. Like it just never caught on. Like in the assembly group, it was never like, oh, of course we'll make an online tool to just do this. Like it never caught on.
Yeah, I mean, at least you can use various tools to like write some code and then generate one or the other. So as long as you have like C source code or something, you can dump the same syntax in both, or the same code in both syntaxes, but it's definitely not as nice as having one of the raw assembly syntaxes and being able to do a conversion. I guess I'm not super surprised that that's a hard problem. I imagine it's not super trivial, but I don't know. I think in the base case, it's got to be like relatively simple. I don't know. Maybe something like IDA Pro does that kind of thing. I don't know. Anyways.
Yeah, so the only error left is the load effective address doesn't like the line for some reason now.
Right. So that's what's going on. In the swap stack function, when it was written in Rust, that was making a reference to like the entry label. So you need to define the label that refers to.
So would I?
And what we want that to be is the location of the entry to the function. So the very first thing in the function definition, it can really just be the label itself, the function label itself.
Okay, so it's okay to be before the directives because the directives don't take up space, or it doesn't matter?
The directives don't take up space. No, they're pseudo instructions.
Okay, so I can just replace the OF rip with the actual label, the Lumen swap stack label, and it should do the equivalent. Okay.
Yeah, so what that does is it loads the effective address of that label into the given register. And then the purpose of that was to be able to calculate the offset, I guess, to the return address, I think.
Okay. Do you know why it was an offset from the instruction pointer? Like why was it OF5 from the instruction pointer?
It's just that's called a rip relative.
Oh no, I get the addressing thing, but I like why was it off by OF? Like why?
Why is the offset that?
Yeah.
I don't recall off the top of my head. I'd have to double check my notes. I thought I had written a comment there, but that code changed and shifted so much that some of the comments might have been removed because I wasn't sure if they're accurate anymore. But I still have some of my notes on that stuff I could go dig through. I'm pretty sure that the purpose of that is we needed that. Shit, man. I am struggling to remember. I'd have to look. Sorry, I can't be more of help. I can take a look today and shoot you a message.
I'm just trying to understand, like, so why do we return to the top of the function? Is it because isn't it like a call where we want to return actually past the point where they called us? Or like I'm confused by that. Why would you return back to the top of the function again? Is it because swap stack needs to return to itself?
I think I don't know, man. Off the top of my head, I couldn't tell you. I gotta look at it again. Been too long since I refreshed my memory there.
Okay.
It's possible that we're not actually using the value in that register anymore.
Oh, we use racks and we put in racks.
No, I mean, I know we use it, but the question is whether we use the value that we're putting in there when we load the address.
We load it and then we push it onto the stack, and then we pop back off and we jump to it. So we do use it as a return address using a jump, as opposed to a return instruction. So I think we're using it.
Oh, that's right. Now I'm pretty sure I remember why. That address points to the return from that function. So I think we're saying that is the return address when the swap to function returns back to swap stack, like it's going to return to the return. So it just bounces back through the swap stack function. You know what I mean?
Okay, so it should still be the entry, or should calculate the actual return address that the call.
I think it might actually be I'd have to double check the syntax, but I think it actually is supposed to be returning or mark the end of the function, like the return. Not like the end of the function, but like right before the return.
Okay.
I will have to double check for you, man, because I'm not 100% sure that that's correct. And if it's not, obviously it will not work properly. Because the thing you got to remember is that what we're doing there in the swap stack function, aside from just restoring registers and stuff, is we're setting up the frame so that the return from that function acts like a call to whatever we're swapping to, and returning from that function needs to find the return address in that swap stack frame that tells it how to get back to the caller of swap stack.
Okay. Well, even with using the label, it's still broke. It thinks we're doing 32-bit addressing mode, and it says it's not supporting 64-bit mode. So I can just wait. Like I don't have a lot of time to work on Lumen anyway, so like I can wait until.
I have to run right now. Actually, I have a meeting here, but I will follow up with you once I've had a chance to confirm what that was trying to do there, and then can make sure that either if we can find another way of doing it, or if we can figure out what's wrong with the syntax there. It's definitely supported, obviously, but I am not sure why it's probably because the label is incorrect. It needs to be referring to the right thing.
Okay.
All right. Thank you, guys.
Talk to you later.
Bye-bye.